Hello and welcome back. In this video we will be pressing on with learning some more trig identities. So in sections 5.4 and 5.5 we'll cover a few things from both sections. But before we dive in, we should remember what a lot of the trig identities we've seen. And the one thing I want you to realize is there are a lot of trig identities, but the tests and homework are all open note. So if you write them down and have them organized, it will be very, very helpful. And I think at some point I will be putting up a sheet of all of the trig identities that you would ever need on Brightspace as well. And I'll send an announcement about that. But for the moment, let's remember a few of these. So we have the reciprocal identities, and these ones are just going to be the sine is 1 over the cosecant. Likewise, the cosecant is 1 over the sine, so we just flip those over to get the other one. The cosine and the secant are the same way. The tangent and the cotangent are the same way. You flip one over to get the other. With the quotient identities, is just the tangent is equal to sine divided by cosine. And then the cotangent, which is the reciprocal of the tangent. If we flip over the fraction, we get the cotangent. So the cotangent is going to be cosine divided by sine, whereas tangent was sine divided by cosine. We had our Pythagorean identities, and this all came from the Pythagorean theorem, x squared plus y squared is equal to r squared. So we had sine squared plus cosine squared is 1, tangent squared plus 1 is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. I think that this is the one that I use most often. Sine squared plus cosine squared is equal to 1. This one comes up occasionally as well. This is a good one to know. That tangent squared plus 1 is equal to secant squared. The third one is the one that, for me, comes up the least often, but it's still good to know that it exists. And if you know that you've got a cotangent squared, well, there is a Pythagorean identity that contains that. We also had our even and odd identities. So with the sine and the tangent, these guys were our odd functions, which means that if we see a negative sign inside the function, we can pull it out. The cosine was the even function amongst the usual three, sine, cosine, and tangent, where if we see a negative sign in there, it's the same as if we took the positive version of that angle. So the cosine of negative theta is the same thing as cosine of theta. The negative sign in the middle doesn't really affect things. We had all of those guys, and then we had our co-function identities. This is something that we saw fairly early in the semester, but we reviewed it a lot in the last section. If we have complementary angles, we can plug them into the co-functions, so sine and cosine, tangent and cotangent, secant and cosecant. If x and y are complementary, then the co-functions are going to be equal. Sine of x is the cosine of y. Tangent of x is the cotangent of y. Secant of x is going to be equal to the cosecant of y. So complementary angles are quite nice with our co-functions. And then the most recent thing that we did was the sum and difference of cosines. So if we have a cosine of two angles that are being added together, we have a formula for this, and we can break it apart. It's going to be the cosine of the first angle times the cosine of the second angle. And with the cosine, the sign switches. So if we're adding in the middle, we're going to subtract out here. So cosine of A, cosine B, minus sine A times sine B. And the same way with the negative sign, it's going to be cosine A, cosine B, plus sine A, sine B. So these were what we saw last time. We'll use these again today a little bit, but before we use these guys, if we have a sum and difference formula for the cosine, we were also going to have some sum and difference formulas for the sine and the tangent. And these guys look a little bit different, but they are remarkably similar. So for the sine, we're going to have sine A cosine B plus sine B cosine A. So what we notice is that we'll start with sine A because those are the ones that are closest together here. So this is how I remember it. So we have sine A, cosine B plus, and then we reverse it, sine B and cosine A. With the negative sign, this just pops out as a negative sign in the middle. So unlike the cosine, the sign stays the same for the sine function. So this is just one thing that you'll have to remember. So we have a formula for sines and cosine, for sines of sums of angles and sines of differences of angles. And if we really wanted to, we could go through and actually derive the formula for tangent of A plus B, because tangent is just sine divided by cosine. So I know what the sine of A plus B is, and I know what the cosine of A plus B is, so I should know what the tangent is. And then if you go through that process, this actually simplifies quite a bit. So this is going to be tangent of A plus tangent of B divided by 1 minus tangent of A times the tangent of B. So this is yes, sorry. So this is our formula for tangent of A plus B. We just get tan A plus tan B over 1 minus tan A times tan B. And the extra negative sign will change things just a little bit. Essentially, anywhere that we see a B, we're going to flip the sign in front of it. So we've got 1 plus tan A tan B. So we've just got a couple more formulas. And again, these are, they're not too hard to memorize, but what's most important is that you write them down and you have them available to you in your notes. So we can take sine and tangents of sums and differences of angles now. So let's use these to solve a couple of questions. So let's find the exact value of these guys without a calculator. So when we say without a calculator, we should think, okay, there are a few angles that we know how to take sines and cosines of and tangents of. So for instance, all of the multiples of 90 degrees. So we can take sines and cosines, we can take trig functions for 0 degrees, 90 degrees, 180 degrees, these sorts of things. But also the special angles in between, 30, 45, and 60. These are our special angles. So for instance, for tangent of 15, when I look at this, I go, well, I don't know what the sine or cosine or tangent of a 15 degree angle is. But I know, for instance, 30 degrees, I know 45 degrees, I know 60 degrees, and I can make 15 using some of these. For instance, this is the same thing as the tangent of a 45 degree angle minus a 30 degree angle. And yeah, so we have so we know that the tangent, we have a formula for the difference of angles here. So I know what the tangent of a 45 degree angle is. I know what the tangent of a 30 degree angle is. Let's split it up and plug everything in. So using our formula, this is going to be the tangent of a 45 degree angle minus the tangent of a 30 degree angle all over 1 plus the tangent of a 45 degree angle times the tangent of a 30 degree angle. And here we'll just have to remember what these guys are, and maybe it's a little bit hard at times. So we can draw some pictures. So a 45 triangle where those guys are the same. I remember this by going, okay, if those side lengths are 1, that side length is the square root of 2, and the tangent of this 45 degree angle is going to be the opposite over the adjacent. So the tangent of a 45 degree angle is 1 divided by 1. So I can replace tangent of 45 degrees with 1. So the last thing to do is the tangent of a 30 degree angle. So for a 30 degree angle, we've got our 30, 60, 90 degree triangle. And the way this triangle is laid out is that the opposite side and this hypotenuse are a 2-to-1 ratio, and this guy was the square root of 3. So the tangent, which is going to be the opposite of the 30 degree angle over the hypotenuse, is 1 over root 3. And that's it. So then we can just simplify this fraction. And I see that we have 1 over root 3's in here, and maybe I don't like those fractions. So what I'll do is I'll just multiply the top and bottom by the square root of 3. And I'll simplify this. So the top, if I multiply the 1 by the square root of 3, that's just going to be the square root of 3. 1 divided by the square root of 3 times the square root of 3, that's just going to be minus 1. The bottom, 1 times the square root of 3 is just this 1 over the square root of 3. So I've got the square root of 3 plus 1. And that's our answer. So we could just use our special triangles to solve for the tangent of a 15 degree angle, even though none of these have a 15 degree angle in it. Let's do one more. So here I've got the sine of a 195 degree angle, and here it's maybe not quite as obvious what's going on here. 195, if I want to add or subtract angles from one another to get 195, there's a few ways to go about doing this. And for me, I like angles between 0 and 90. I think angles between 0 and 90 are a little bit easier to deal with. So here's the first thing I'm going to do. I know what the sine of multiples of 90 are. So I can take out 180 degrees and rewrite this as 180 degrees plus 15. 180 degrees is one of these ones that's fairly straightforward to take because it's a multiple of 90. It's 0, 90, 180 degrees, 270, 360. These are fairly nice. So let's do this. If I've got sine of 180 times cosine of a 15 degree angle, plus the sine of a 15 degree angle times the cosine of 180 degrees. So here we just need to know what the sine of 180 degrees is. So when we think about 180 degrees with our sine function, we know that so at 0 degrees we're going to be at 0. At 90 degrees we're going to be at 1. At 180 degrees we're going to be back down to 0. So this right here is in fact just 0. So it doesn't even matter what the cosine of a 15 degree angle is because I'm just multiplying by 0. So that whole term goes away. And then we have the cosine of 180 degrees. The cosine starts at 1, falls down to 0, comes down to negative 1, comes back up to 0 before coming back up to 1. So if 0 degrees is at 1, 90 degrees is at 0, 180 degrees, that's at negative 1. So this simplifies down quite a bit. This is 0. This whole term is 0 because I'm multiplying by 0. This has a negative 1. So this is just going to be negative sine of 15. And from the previous question, we saw that, 15 degree angle, let's say 45 minus 30. So I can write this as a sine of a 45 degree angle minus a 30 degree angle. And I will finish that question in the next video.